Hello, everybody. Today we're going to be starting week 4, day 2. That's 8.4. Moving on right to the next lesson. So let's jump right in. First thing we're going to talk about is the definition of the nth root. Now, some of the stuff in this actual lesson is actually going to be a little bit of a review that we practiced right after we got out of school, right in the middle of March there. So one of these things you've actually learned before, we learned how to rewrite this nth root of x as something different. It also means that it's x to the what power without having the radical sign. Remember, that's 1 over n. This n here, whatever number is inside here, needs to be the denominator. That's nothing new. So I'm going to practice using that in a little bit here. Okay, the geometric mean. This is when you take a set of numbers and multiply them together. And then you take the nth root. If you don't know what that is, you just refer back up to here. Nth root, that means you put the little number here on the n and do the root sign. Nth root of the number of values that are in the set. This is a way to calculate a different type of average. So geometric mean, you probably maybe not have heard that word before, but you might have heard of the arithmetic mean, or you also know what this word means. It is the average. But this is just a different way of finding the average. And sometimes this is actually preferable depending on what type of data sets you have. So you guys are kind of used to maybe doing the average by like adding them all together and then dividing by the number of numbers you have. This is just a different way of doing it, called the geometric mean. So we're going to try an example like that. And I'm just going to do this stuff in a calculator. I have like a normal calculator to use that should be very similar. Like if you have a phone or on your laptop, you probably have the same calculator. You just type in calculator at the bottom and it works. And just bring it up and click on it. So you can use this on your work if you want to. You don't have to have a graphing calculator to do these problems. Okay, for example 1, find the geometric mean for the shoe sizes in John's family. So it gives us all the shoe sizes. So what do we have to do? If we go back up to the box, it says this is when you take a set of numbers and you multiply them together. So let's do that. 9.5 times 7 times 6.5 times 11 times 12.5 times 8 times 6. 1. And then we have to figure out how many there are. Then we're going to take the nth root of the number of values. So how many are there? Well, 1, 2, 3, 4, 5, 6, 7. Did I use all of them? 1, 2, 3, 4, 5, 6, 7. Okay, I got all 7. So we're going to take the nth root. So we're going to do the root symbol of all these numbers multiplied together. And since there's 7, we're going to do the 7th root. So what we can do first is we can multiply all the numbers on the inside first. So it'll be the 7th root of, and you can do this in the calculator. Just bring that up. You're going to get a pretty big number. So 9.5 times 7 times 6.5 times 11 times 12.5 times 8 times 6, right? So 8 times 6 equals pretty big number. So I'm going to use that. 2,852,000. 1,052,000. And what else was there? 850. Now we don't have to actually put this 7th root in the calculator. We can actually change it by using this up here. If you go back up here, we can change this root symbol to a exponent, power. They call that a rational exponent. So I'm going to do that. I'm going to rewrite this as the 2,852,850. That whole thing can be raised to the what power? If you have the 7th root, that'd be 1 over 7. So I can do that in this calculator pretty easily. if you look at this button here, it says x to the y. We can do that. So you press that button, and then if you look up here, there's like a little caret, and we put 1 divided by 7. Hopefully it does the whole thing. May not. I don't know. It did not work. Okay. So I think you have to put parentheses in it. So let's put that in here again. So I did this problem on my phone, and it automatically puts parentheses in there when you hit this button, the X, Y. But now we have to put the parentheses in there. So if you can see that tiny thing up here, 1 divided by 7. Now it should work, hopefully. Equals? Yeah. So once you type it in there, you have to hit equals, and then it works. I don't know what number it was given me before, but as soon as you hit equals, as long as this looks correct up here in this little tiny box here, then you should get the right answer. So we'll round this to, say, 2 decimal places, 8.36. And that's the geometric mean. And if you look at all the numbers that we started with, it is pretty close to probably being the middle number, 8.36 out of all those ones. So it's a different type of average. Our example 2. Evaluate each expression and see how they compare. I'm still going to use the calculator and see if we can get the right answers this way. Although I prefer to use my phone calculator than this one. This one's not that great. But if that's all you have, you can still use it. So the first one, 625 to 3/4 power. Well, we've dealt with this before. We can rewrite this as 625 to the 1/4 power and bring the 3 to the outside. I don't know if you remember this, but we used our chart for a lot of problems like this, exactly like this. So if you have your chart, you can look this up. 625 to 1/4 is the number 5. I'm not going to waste time looking these up. I already know this answer. And 5 to the 3rd power, you can also use a chart, is 125. Okay, for part B, what if we had the 4th root of 625 cubed? So I'll do the inside part first and cube this number. 4th root of, what is 625 cubed? You can just multiply that in here. 625, let's see if this works here. Hit the X, Y button, 3 equals 244,140,625. 140,625. Did I get it right? Okay. And then we're going to do the 4th root. Though you don't have to write it as a 4th root, we can do it as a power like we did in the previous problem. So we can write this as 244,140. I also don't think these calculators do 4th roots. At least I don't see it on there. So you kind of have to rewrite it like this, 1/4 power, and then put it in here as that. Because I don't see the 1/4 power on here. I don't see it anywhere on here. So we just have to raise it, hit the X to the Y, make sure you put in parentheses. What did we say parentheses was? 1/4. 1 divided by 4. End parenthesis, then hit enter. And it is 125. Any guesses what the last one might be? Kind of looks similar to the other ones. So the last one, it says what's in parentheses is a 4th root of 625. You got to do that first. So that is going to be in your chart as well. 4th root of 625 is 5. And then we'll cube it. 5 times 5 times 5 is 125. So if you notice, all the answers that we just got are the same. Really, what's the difference between these problems, A, B, and C, is that they're just written differently. And that's one of the properties that we're learning today, is how we can rewrite these. Again, I did kind of go over this a little bit before we left school, the specific property. I'm not sure if we used part C at all, but we did look at A and B. So that leads us to roots of a power theorem. For all positive integers m and n, as long as they're bigger than or equal to 2, then we can use this property. If you have the nth root of x to the m, one thing you can do is, that's like going from part B and rewriting it like part C. What are they doing there? They're basically just taking out that 3 and putting it to the outside. So in this case, we can say this is the nth root of x, and the whole thing in parentheses, to the m. So whether or not it's inside with the x or outside in a set of parentheses, they mean the same thing. And the last way you could rewrite it is by getting rid of the root and writing it like part A. So that would be x to the m over n. As long as you remember that the small number inside here is always the denominator, you should be okay. Let's practice one of these ones. Example 3. Suppose x is greater than or equal to 0. Use the root of a power theorem, which is the one right above, to rewrite this 6th root of x to the 18th power in 2 different ways. Not too difficult. Just basically going to copy how it looks at the top. We're going to go from this form, then change it to this one, and then to this one. So one way to do it is we do the 6th root of x to the 18th. We're going to put the 18 to the outside. So 6th root of x to the parentheses 18. That gives you the second step up here. Then we're going to do it one more time. Rewrite this as x to the 18 over 6. And you can reduce that once more, which is x to the 6 goes into 18 3 times. So I actually wrote it in more than two different ways. I wrote it in 3 different ways, but that would be like the process. You can go through all these steps. You don't always have to do this middle step. You're kind of familiar with going from the first to the third and then simplifying from there. So you've seen this before. Next page. Practice a couple of these. Just simplifying them this way. Simplify the following expressions to exponential form, which is important. That means they want you to have it just as an exponent, as long as x is greater than or equal to 0. Again, you can't have negative numbers inside these roots, especially if they're even roots. So the 7th root of x to the 35th would be the same thing as x to the what power? 35 over 7. We can kind of skip the middle step. We don't have to pull 35 out. We already know how to do this. Then simplify this. 35 over 7 is 5. So it's x to the 5th. All right, and then b, if you have the 6 on the outside, that means it's still the top number. So this would be x to the 6 over 9. Remember, this is always the denominator, which is the same thing as x to the 2/3. All right, last one. Cube root of x to the 21st. That'd be x to the 21 over 3, which is x to the 7th. Okay, we're almost done. Last bit here is roots of roots. Looks a little bit more complicated. Not terrible, though. So there is like a long way to do these kind of problems when you see a bunch of roots stacked on top of each other. I prefer not to do that way, so I'm going to kind of teach you like a shortcut on how to do it. May not be like 100% mathematically correct, but I feel like this is like the best way and the easiest way to know how to do these. So if you look at this, we actually have 3 of these root symbols. These are all square roots. So we're going to rewrite this mess using rational exponents. So it's going to be, 6 to some power. It'll be the goal. So if you look at this, we can actually look at the number inside here with the square root of 6. And you might be able to say, can we do the square root of 6? Like just look at this first one inside here. Well, 6 is not a perfect square, so we really can't do anything with it. So what we're going to do is we're going to condense these root symbols. We have 3 of them. These all are square roots because there's no number there. But what number would be there since we don't see it? They would all be 2's. Square root means there's a 2 there. I've said it before, you just need to remember that. Whenever you see a square root, that means there's 2's there. So how do we condense this into one just root symbol? So this is some root of 6. We can just multiply the 2's together. So we have 2 times 2. These 2 would give you 4. And then you do 4 times 2. So this is actually the same thing as the 8th root of 6 as one root symbol. Now they don't want that as a final answer. They want us to use rational exponents. So we're going to rewrite this as 6 to the what power? 1 over 8. And that would be something you could actually evaluate in the calculator. Whether you have a phone or they use the computer. Our example 6. Same idea, just different numbers now. We have a square root, a cube root, a fourth root, and then 15. Again, see if you can actually simplify this inside here, fourth root of 15. That number is not in the chart. 15 is just 3 times 5, so you can't do anything with that. We can still put a 2 here because it's a square root, and we're going to do the same process. We're going to multiply all these indexes together. So we're going to have 15 as a root, but now we got to figure out what this number is here. That's going to be 2 times 3 is 6. 6 times 4 is 24. So it's a 24th root of 15, or 15 to the 1 over 24th power. We're not solving this right now. It just says to rewrite it. So make sure you read the directions of these problems. You do not have to put that in the calculator. The last one said the same thing, rewrite. Example 7. Rewrite this. We have 1, 2, 3, we have 4 square roots of 81 using a radical sign. Again, this one, you should always look on the very inside and see if you can simplify what's in here. Kind of ignore all the square roots except for just the inside one here, the square root of 81. So we can actually get rid of this square root because 81 is a perfect square. What is the square root of 81? That's 9. 9 times 9 is 81. So we can get rid of this square root and just get it to be 9 and get rid of this one that's up here. And how many would we have left now? 1, 2, 3. We still have 3, so we still have to draw 3 of these. But that's one less than we had from before. Now if you look inside here, square root of 9, can you do that? Yes, you can. So we can actually get rid of another square root symbol by changing this to the number 3. Square root of 9 is 3, and that gets rid of this square root symbol, and now we only have 2 left. So sometimes you can actually simplify the number that's inside there first, maybe once or twice or more than once, and then you have less to work with. Since they're both square roots, put little 2's there. We can multiply them together. This is the 4th root of 3, or 3 to the 1/4 power. And that would be your final answer. So I went a step further. I guess it says use a radical sign. So if it says use a radical sign, then they probably want this as your answer. So you don't have to go to this next step here if you don't want to. I went a little too far, I guess, using the directions. So if it says a radical sign, you can stop here. If it said rational exponent or a fraction exponent, like these ones up here, you have to make sure you go to this step down here. Okay, example 8. Write each expression in simplest radical form using no fraction exponents. Assume positive variables. Okay, these last two are a little bit harder than the rest. So let's see if we can do this. And you also notice there's no numbers in here. All these have variables as the base. So how do we solve something like this? We have 2 square root symbols and y to the 1/4 power. Let's do what we've been doing before and condense these two. They're both square roots, so put 2's on them. So this would be the same thing as the 4th root of y to the 1/4 power. I just did 2 times 2 in here. Then I'm going to remove this right now. Actually, maybe I'm trying to think what would be the best way to do it. You can do it one of 2 ways. We can either rewrite the 1/4 as a root symbol going backwards, or we can write this 4th root as a power and then go backwards. You can do it either way. So one way to do this would be the 4th root and writing the inside as a root. If you have a 4th power, that's another 4th root of y. So y to the 1/4 is a 4th root of y. So now we can condense these together and do 4 times 4 and get 16. So this is 16th root of y. And since the direction says put it in simplest radical form with a radical symbol, not using a fraction exponent, then this would be your answer. Another way to do this problem, I'm just going to cut off here and do it the other way. Based off of this, you could write the 4th root on the outside, this big 4th root here, make that as a 1/4 power. So you could have y to the 1/4 on the inside, and then another 1/4. Then you can multiply these together, go across the top and bottom, which would be y to the 1 times 1 is 1. The bottom would be 16. And then you could rewrite it like the final answer, 16th root of y. I don't really care which way you do it, but the final answer has to be the same, has to have the radical symbol. All right, last problem. The square root of k to the 1/2 divided by the square root of k. All right. So I'm probably going to work with rewriting this k to the 1/2 like I did over here when I had a 1/4. I can write this as a square root of, what's k to the 1/2? The square root of k. The bottom, if you notice, square root of the square root of k is the exact same thing. So if the top is the same thing as the bottom, what happens? They would end up canceling out. You can go a little further if you want. You could multiply these together, and you could say it's the 4th root of k divided by the 4th root of k. But you don't have to do this step. As long as you have the same thing on top and bottom, they cross each other out and you get 1. So this one actually does not have a radical form. There's no fraction exponents. It's just the number 1 because they would cancel each other out. Okay, so this was for Wednesday, April 22nd. Please finish the assignment on this and then take a picture of it and send it to me in an email. And if you have questions, you can also ask as well. And we'll see you next week.